Everyone, just one more lecture and then we're going to really get into some example problems, and I will go through every single one I can for you. So we're talking about resultants and components. Resultants and components. So what does that mean? Well, if we have a force system, like in this case we have a couple of tugboats pressing on a barge. We're trying to figure out, well, what's the effect of these tugboats pressing on this barge? What we need to do is we need to add all those forces together. So how do we do that? Well, there's a bunch of steps. First off, you're going to draw a picture of the force system. So you'll take that picture, that's a real life picture, you turn it into something more cartoony. Then you're going to draw a free body diagram of the force system at a particular point. So in this case, I'm going to choose this point where their line of actions intersect. That's usually a good place to start. I then keep on going and I draw a force triangle. So you see I have one going down and one going to the left. Well, I can kind of connect those. This is how you add things geometrically. I mean, if you had graph paper, you could literally solve problems without doing any math. You just have to draw things to scale and then measure it. And so I draw my force triangle, first down and then over. And what I know is that if I add those two together, when I add things geometrically, I go from the beginning of one to the end of the second. And so this arrow right here, the hypotenuse, would be my answer. Now, if you remember, we did all that trig practice in class, and we did that for a very good reason. Because if we're trying to add these components together, you can see that, oh, if these are right angles, well, I can use Pythagorean theorem to help myself. And you can. Or law of cosines, or law of sines. There's lots of ways where that would come in very, very handy. So, using our known signs, we add it together to get the resultant force. Then we can solve for the direction and angle of force using our trig functions. So if we're looking for theta x right here, well, what would that be? That would be opposite over adjacent. So tan of theta x would be equal to py over px. And I could solve that. Oh. So now let's actually try this out. We'll do one example problem today, and then I'll put the rest in a bunch of separate videos. So, example 2.1. We have the rectangular components of a force acting at a particular point. We have 100 pounds in the y direction and 200 pounds in the x direction. But this is going in the negative x direction. And they both act at this point O. It's saying calculate the magnitude, inclination, and the sense of the resultant force. And I'm being nice here. I give you this right here. We're looking for P. We're looking for this big, long hypotenuse line. Okay. Now, I would let you go and do this, but let's do one example together. So in future ones, I'm going to give you a moment to probably try this on your own. But here, we'll do it together and see how it goes. Okay, so we've got 100 pounds going up, 200 pounds to the right, or sorry, 200 to the left. Now let's see if we can calculate this. Now first, we're going to have to calculate the magnitude of the resulting load P. If I draw it like a triangle, it makes a lot of sense. This is 200, this is 100, and I have one connecting it. If I get rid of the arrowheads, that's just a triangle. It looks completely normal, and we can use Pythagorean theorem to solve it. So, it's going to be the square root of the components squared, and then added together, which will come out to be 224 pounds. And you see that when it comes to magnitude, that negative 200 doesn't matter. It doesn't matter if it's positive 100 because they're always squared. Okay, now what's the angle of inclination? Well, we're going to use tan to negative first, of opposite over adjacent. So you see that this is the y direction right here. This is the x direction. They also called it px and py. So if this is the angle I'm looking for, which it is, opposite over adjacent would be py over px, which is what we get right there. And so that'll be 100 pounds over 200 pounds, which comes out to be 26.6 degrees, which at least in this case does visually match up. As a note, not all the problems I have will be to scale. I do randomize the numbers, so sometimes it's going to be off. Okay, so there we go. Try out a problem, and next time, just be on the lookout. I'll have a whole bunch of example videos to show you how to do this step by step, and you can also try all the practice. So thank you so very much. Bye-bye.